Alright, this is 3.6, the chain rule. So students will be able to use the chain rule to take derivatives. Now, we use the chain rule when we have kind of an f of g situation. Anytime you have a function inside of another function, like if you had f of g of x, you take the derivative of the outside, the f prime, leave the inside alone, take times the derivative of the inside. Oh look, it's written right here. That's the chain rule in words. Derivative of the outside, leave the inside alone, times the derivative of the inside. Let me show you what I mean. It says, each of the following examples can be done without using the chain rule. First state how to find the derivative without using the chain rule, and then use the chain rule to differentiate. Well, this one is a quotient rule. You would do low d high minus high d low over the square of what's below. Or, you could save yourself some time and rewrite this, okay, as 2 times 3x plus 1 to the negative 1. Now, here's the chain rule. That's entirely too big. Hold on. Why is that so big? Why didn't it make it go away? Okay. It made everything go away. Negative 1. Alright. This is my outside function. So what if I had, let's just pretend for a minute, that I had 2 blah, let's just blah, to the negative 1, okay? It would be, I would multiply the negative 1 to the front, negative 2 times, let's just call it x or whatever, to the negative 2, okay? That would be how I would do that. Well, what I'm going to do here is I'm going to do that exactly that. I'm going to do negative 2, leave the inside alone to the negative 2, and then I multiply times the derivative of the inside. Well, what's the derivative of the inside? 3. So it would be negative 6 times 3x plus 1 to the negative 2, or you could write it as negative 6 over 3x plus 1 squared. Now, if you did low d high minus high d low over the square of what's below, you would get the same thing. Let's look at another one. Here, my outside function is something cubed. So what if I had x cubed over here? What would be the derivative of that? Well, it would be 3x squared. That's what I'm going to do, but it's just 3 times whatever squared, times the derivative of whatever. So I'm going to take my 3, multiply it to the front, 3, leave the inside alone, x squared plus 2, subtract 1 from my exponent, times the derivative of the inside. The derivative of the inside is 2x. So if I wanted to clean it up, I would get 6x times x squared plus 2 squared. That's the chain rule. Let's look at this one. I've got sine is my outside function, and the 2x is my inside function. Well, what's the derivative of sine? Well, I always have to come over here to the side. Sine, cosine, negative cosine, sine. So, my derivative of sine is cosine. Leave the inside alone times the derivative of the inside, which is 2. So, it would be 2 cosine of 2x. And I'm not doing the inside and the outside. Whoops, I'll go back and do that at the end. I mean, I am, but I'm not. Yeah, no, I don't want to go back. I'm doing it as along. On this one, the outside function is the square root, and the inside function is the 3x squared plus 1. So I'm going to rewrite it, first of all. I'm going to say that my f of x, and I really need to do better with my notation. Let me go back and do all these. F prime of x equals h prime of x equals. So f of x is 3x squared plus 1 to the 1/2. If I rewrite my square root. So I'm going to take the derivative of the outside is the 1/2. So the derivative, move the 1/2 to the front, 1/2, leave the inside alone, don't touch it, to the negative 1/2 times the derivative of the inside. The derivative of the inside would be 6x. if you wanted to clean that up, you don't have to, but if you wanted to clean that up, a half times 6 is 3x over negative 1/2 is the same as the square root on the bottom, because I divided the 6 by 2. Let's see. Ooh, combining all the rules. We have a power, a product, a quotient, and a chain. Fun. So I'm just going to rewrite this initially. K of x. It's always easier to rewrite your square roots as exponents. I'm fixing to have to sneeze. No, it went away. No, I'm about to sneeze. Okay, I think I'm alright. First of all, I need to say this is a product rule. This is my 1. Here's my 2. So, here we go. 1, x squared plus 1. Derivative of the second. Now, this is a chain rule. I don't know if you recognize, here's my outside function, and 2x minus 3 is my inside function. So, derivative of the outside would be 1/2, leave the inside alone, to the negative 1/2, times the derivative of the inside is 2. So that's 1d2 plus 2x minus 3 to the 1/2. d1, the derivative of x squared plus 1 is just 2x. And we can leave that. I do not feel the need to simplify that. No. Well, might as well. K prime of x. The 2's would cancel here. And really, you need to recognize that this negative 1/2 moves to the bottom and becomes a square root. So this is x squared plus 1 over the square root of 2x minus 3 plus 2x times the square root of 2x minus 3. No need to go further. That's good enough. Find and remember dg dt. All that means is that's the same as saying g prime of t. I want to find the derivative of g with respect to t. This one is a chain rule. Whoops, I've been doing the outside in blue, right? Chain rule. The inside is pink. So the inside function is t minus 2 over 2t plus 1, and the outside function would be like x to the 9th, or t to the 9th. So, chain rule. Derivative of the outside would be 9 to the 8th. Okay? Leave the inside alone. Times the derivative of the inside. I'm just going to put this in a big bracket. The derivative of the inside is low, d high, minus high, d low, over the square of what's below. And I'm going to leave that just like that. I am not going any further. And example 5, for each of the following, use the fact that g5 equals negative 3, g prime of 5 equals 6, h of 5 equals 3, h prime of 5 equals negative 2 to find f prime of 5, if it is possible. If not possible, state what additional information is required. So the first thing I want to do is take my derivative just in terms of x. This is a product rule. 1 d2 plus 2 d1. And I'm going to fill in my 5 now. G of 5, h prime of 5, plus h of 5, g prime of 5. G of 5 is negative 3. H prime of 5 is negative 2. H of 5 is 3. G prime of 5 is 6. So that 6 plus 18 is 19, 20, 21, 22, 23, 24. You didn't see, but I just counted on my fingers. B. Chain rule. Derivative of the outside. Wait. Notation. F prime of 5 equals F prime of x equals F prime of x, derivative of the outside, g prime, leave the inside alone, times the derivative of the inside, h prime. Fill in my 5. So g prime of h of 5 times h prime of 5. Now we got to be careful here. G prime, h of 5 is 3 times h prime of 5. G prime of 3, oh, I don't know that. That's the additional information. I don't, IDK. I'm just going to give that like y'all do. I know this one, times negative 2. I don't know times negative 2 is I still don't know. ISTDK. So the additional information that's required is I need to know that right there, and I don't have that. This one is low. Whoops, that is not low. And I need to say f prime of x equals low d high minus high d low over the square of what's below. And I'm going to be lazy and just do this. 5, 5, 5, 5, 5. Let's see, h of 5 is 3 times g prime of 5 is 6 minus g of 5 is negative 3 times h prime of 5 is negative 2 over h of 5, 3 squared. 18, see, 3 negatives is a negative. 3 times 2 is 6 over 9. 18 minus 6 is 12 over 9. That's f prime of 5 equals. This one, chain rule, the derivative of the outside, leave the inside alone, times the derivative of the inside. And this is of 5s. And this is f prime. Gosh, I forget to do that. G of 5 squared times g prime of 5. And I think I know everything here. G of 5 is negative 3 times g prime of 5 is 6. Yeah. Negative 3 squared is 9 times 3 times 6. 3 times 9 is 27 times 6. Oh, I don't know. 54 times 3 might be easier. 2, carry the 1. 5 times 3 is 15. 16. 162. Maybe, as long as I didn't do that wrong. And that's all. We're not doing that out of the book. I don't think. No, we're not. Okay, that concludes 3-5 notes. Make sure you fill them in for me, please.